Hello everyone, in this video tutorial we are going to look at the integration of partial fraction whereby the denominator has a linear part and a quadratic part. So the first thing what you do is that you factorize this denominator. X squared minus 1 is it can be factorized as x plus 1 into bracket x minus 1. Then this other part, x squared plus 4, cannot be factorized further. After that, now you write it in form of fraction. So here we are going to have a over x plus 1 integral plus b over x minus 1 integral plus cx plus d over x squared plus 4. We write this one this way because of x squared. Then from there now, the objective is to obtain the values of a, b, c, and d, which are a constant. So what we are going to do, we are going to multiply both sides by x plus 1 multiplied by x minus 1 multiplied by x squared plus 4. So that is what we are going to do both sides. And on the left hand side, when we multiply with this, we are going to be left with x squared plus 9, which is equal to, here when we multiply with this, x plus 1 will cancel and you are going to be left with the a into bracket x minus 1 multiplied by x squared plus 4 plus b into bracket x plus 1 multiplied by x squared plus 4. The last part will be left with the plus cx plus d multiplied by x plus 1 multiplied by x minus 1. So when you look at this, we are going to set the value such that we eliminate some of the unknown and get one of the unknown. So when we look at this, for example, if we set x to be 1, it means that a will be eliminated, and also these others will be eliminated, and we shall be able now to obtain the value of b. So we set x is equal to 1. So when you set x is equal to 1, you are going to have we substitute here 1 squared will give you 1 plus 9, which is equal to this other part here will reduce to 0 because 1 minus 1 is 0. So here we will have 0 plus b into bracket 1 squared is 1 plus 4, which is 5. That part here you will have 5 here. Then you have 1 plus 1, which is equal to 2. 2 plus the final part here, you have x minus 1. So the last part will reduce to 0 plus 0. This is 10, which is equal to 10b. So you divide by 10 both sides. So you have 10 divided by 10, which is equal to b. So our b is equal to 1. Our b is equal to 1 from there. Then we can set x is equal to -1. When you set x is equal to -1 squared is 1 plus 9. It will give you 1 plus 9, which is equal to a into bracket -1 will be -2. 1 squared is 1 plus plus 4, which is equal to 5, plus this part here on B will reduce to 0, plus, so this part here, because of 1 minus 1 will reduce to 0, and the last part because of 1 minus 1. So the last part will also be 0. So here you have 10, which is equal to negative 2 times 5 will give you negative 10a, meaning that our a is equal to negative 10 divided by 10, which is equal to negative 1. So the last part now, we want to get D and C. So we can set x to be equal to 0. When we set x to be equal to 0, we see what we are going to obtain. Setting x is equal to be 0. On the left hand side, we will have 0 plus 9, which is equal to, here we have obtained our a. Our a is negative 1 into bracket, negative 1 into bracket 4, plus our b is 1 here, into bracket 1 into bracket 4, plus this other bit here. Here you have z0 plus d into bracket 1 into bracket negative 1. This sign is 9, which is equal to 4 plus this is 4 plus, here you have c will reduce to 0, d you have minus d. So here you have 9. 9 is equal to 8 minus d. Then you have 9 minus 8 is equal to minus d. You have 1 is equal to minus d. This tells you clearly that our d is equal to negative 1. So the next thing we set our x to be equal to 2. So 2 squared is 4. 4 plus 9, which is equal to, now our a, we found our a to be negative 1. So you have negative 1 into bracket 2 minus 1 is 1, into bracket 2 squared is 4. 4 plus 4 is 8, plus our b is 1. Our b is 1. So you have 1 here into bracket 2 plus 1 is 3. You have 3 there. Multiplying by 2 squared is 4. 4 plus 4, 8. Plus our c we don't know. So c times 2, here you will have 2c plus d. Our d we have found it is negative 1. So plus negative 1 into bracket 3 multiplied by 1. 3 multiplied by 1. Then 4 plus 9 is 13, which is equal to negative 8. Negative 8 plus negative 8 plus 1 times 3 is 3. 3 times 8 is 24. Plus here you have this is 2c minus 1. We multiply everything down by 3. So you will have 6c minus 3. 6c minus 3. So this side negative 8 and 3 will give you negative 11 plus 24 plus 6c, which is equal to 13. So clearly here we can when we take negative 11 plus 24 it will give us 13 plus 16. So 13 minus 13 is equal to 6c. 0 is equal to 6c, which implies that our c is equal to 0. So we have obtained our constant. We have obtained that our d is equal to -1. Our a is equal to -1, and our b is equal to 1. So once we obtain the constant, then what we are going to do, we are going to substitute our constant in this equation. So now, since this is what we are solving, we are going to substitute the value of constant. Our a is -1. So we will have negative integral of dx over x plus 1 plus our b is 1. So you have integral dx over x minus 1 plus our c is 0. So c times 0 will give you 0. D is -1. So you will have negative integral of dx over x squared plus 4. So the integral of this one is natural logarithm modulus of x plus 1 plus natural logarithm of x minus 1. Now the last part here, we are going to deal with it in the following way. So to integrate dx over x squared plus 4, we note that in general, if you are given dx over x squared plus a squared, then the result is 1 over a tan inverse of x divided by a modulus, of course, plus a constant. So that is the fact we are going to employ in integrating this part. So in our case here, our a is equal to 2. So integral of dx over x squared plus 4 will be equal to 1 over 2 tan inverse modulus of x over 2 plus c. So finally, so the integral of this is equal to what we have obtained here. We can combine these two. Is equal to natural logarithm modulus. We start with the positive one, x minus 1 divided by x plus 1 modulus minus half tan inverse of x over 2 modulus plus constant c. So that is how we obtain the integral of this equation by integration using partial fraction, whereby we have written this in terms of linear fraction, and this other part which is a product of quadratic bit. So bye. Thanks so much for watching this video. Remember to like, to subscribe, and also to share with the other mathematicians so that we may learn together. Remember to click on the notification bell so that you don't miss a single video which I upload every day, and particularly now we are looking at calculus 2. Bye. See you in the next video.